Hello everyone, welcome to our live event about the report of our progress. As you can see today, I'm starting this meetup with Lynx, one of Lynx Prototypes on my head, and I'm very excited as all the team that is behind the camera to show you our progress today. So first, I want to make sure that everyone is safe and not too much impacted by the COVID situation. And I just want to say that as the time we're speaking now in France, where we are today in our Paris office, we will know in about 1 hour or two what our president will do with us about the lockdown or not. So the situation is pretty tense, and again, I hope everyone is safe. So we'll start today by showing you many different things. So the first one, obviously, is the Lynx prototype that I'm wearing today on my head. Because many people were waiting for us to show the device after the redesign we announced in July. And I think today we're ready to show that and our progress. So to begin, you can see that this is a black prototype. We will make a video later about what you can see through the device, through the lens. I will give it to Shuki here. Thank you very much. And we'll continue the presentation today with all the new features that are coming with the redesign we announced in July. So, Mark, if you can put the presentation in full screen, please. So the new timetable for Lynx, as I told you, 25 prototypes are getting ready, and we'll send them next week to our partners and to our strategic customers. We are thinking about making a video so people can experience the device online. It's a very tough decision, and we have to think a lot about what we shoot with the camera, because through the lens experience is very different than experiencing the device in person, so we'll have to think about that. You will also have to know that the first batch of devices should go out of the factory in December. And also, we have been looking at the price of our device, and we are trying to do a price modification. What does that mean? It simply means that we are trying to lower the price down. We'll never put a higher price on the device, and we are working with our Taiwanese suppliers to see if we can make a better deal for our users and put the price a little lower. And to finish about this quick introduction, COVID has impacted our company quite much, because suppliers of suppliers had delays, and we had to work with this situation like everyone else. I think this year is very special when you realize that even companies like Apple have delays in their products. Like even the masters of the supply chain have delays. So I think it tells a lot, and I'm very thankful for our customers and our first developers to be patient for us to deliver the first devices. So next in line, the very juicy stuff, what we will deliver with Lynx. So the first thing we will deliver with the app is a custom launcher for our VR and AR experience. So we built a launcher that will be open source. You will find a source code on our website, and we will also deliver sample apps that are also open source, and you can use them and modify them to take the device to new heights. We also have a hand tracking. We are working with Ultraleap, especially on their hand tracking technology. We are very proud of that, and we are also working on the controller compatibility. I can tell you today that we are working with the Finch company. They are making 6 DOF controllers, and we are right now evaluating these controllers for Lynx. And the battery, because many people were asking about the battery capacity of our device, so I listed here the capacity of our device, which can deliver up to 4 hours of intense use of Lynx. Again, you have to know that we are pushing the XR2 platform, the Qualcomm XR2 chipset, to its limit with what we are doing with Lynx, because we are doing very high resolution with very high frame rate rendering either in VR or AR. And especially in AR, where you have like the 6 cameras working in parallel, like the RGB cameras, the monochrome cameras for the 6 DOF, and also the eye tracking, all working together with a very high usage of CPU, GPU, and DSP. So we are very proud of what we are doing on the software side as well. So speaking of software, here are a few more details about what we will propose to our developers. So right now I'm speaking to people that want to use the platform in 2021 to build new experiences. So it's based on Android 10. You have access to the 6DOF API, which means that you will have access to the point cloud of the SLAM algorithm. And so you can do plane recognition and stereo reconstruction. We have APIs for that we will expose to our developers. We also have the latest Gemini Ultraleap tracking technology. So we have the best-in-class hand tracking that will work on our device, and we can't wait to see what you're doing with that. We're betting on that interface, just like we're betting on the fact that the foam here, like we are using the foam as an add-on to our headset. And just like controllers are not the primary interface for Lynx, but again, it will be compatible. You can also do remote rendering with Lynx over USB-C or Wi-Fi 6. We are right now testing it and trying to deliver a sample app to our developers. As you can see on the right, we have a Lynx XR provider compatible with Unity, and we are also working with NDI Cloud XR. We're trying to be compatible on the most standard platforms out there, which is Unity today for XR application, and also the NVIDIA ecosystem, which is called the Omniverse. In parallel, we also have OpenXR on our roadmap. We are trying to build an OpenXR layer for developers. So later in 2021, you should see an implementation potentially on Unreal Engine as well. So again, the developers also have access to RGB texture. You have access to the Neural Engine API. We're working with Qualcomm on that. And you don't need a Facebook account or any kind of account to use our device. We're trying to make a device that is very open, that you can customize a lot, which is why you can plug sensors or any kind of accessory through Bluetooth or USB-C or over Wi-Fi. And we will help you doing that. We will support you, and we will publish guides for developers to customize our platform, because we believe that video see-through is just the first step to bringing virtual reality and augmented reality together, which is what we're doing, mixed reality. So one of the other cool features that we're announcing today is our optical plugins. So we have a magnetic mountings on the camera on the RGB cameras. Maybe I can show that on camera, Mark, if you can switch to the camera mode. So it's very suitable for optical zoom. And you can see maybe this is a transparent faceplate of Lynx. And you can see that on the two sides of each camera, we have like two small holes where we put magnets in the faceplate. And we're using that, and we'll publish the 3D file of this particular 3D object. So the hardware developers and optical engineers can design add-ons that you can plug on the faceplate. Thank you, Mark. You can go back to the presentation. We also have a hardware fork for firefighters and soldiers. So again, I talked about that earlier in a previous meeting, but we have a Lynx version with, instead of RGB cameras, we are using HDR cameras. So the headset is a bit bulkier. We'll not show it today, but this is something that we can propose to the defense industry as well as the firefighters that are quite fond of that. It's kind of a headset where you can see through explosion or see through the night and stuff like that. Okay, next one. The Lynx Calibration Setup. So today for this meetup, we have new offices, and we want to show you what is going on behind the scenes and what we're doing at Lynx, especially on the calibration side. It's a very complicated setup because we're calibrating 6 cameras in Lynx. We have also 2 optical blocks. So we'll walk you through our setup, and so you can see really what's going on. So we'll switch to the camera mode with Mark, and we'll walk together through our new offices. All right. So here is where the side of the office where we're doing all the prototyping and all the hardware calibration and mounting and testing. So it's a very small area for the moment because the office is not finished yet, but we can move closer, and on this table, for example, we can see the robot we're using, the robot arm we're using with a prototype here. So this setup here is used to calibrate the 6DoF. So here we have a target, a calibration target, and the robot is doing motions in front of the target, so we can calibrate the IMU and the monochrome cameras together. So that's for the 6DoF. And then the robot switched to looking at the ceiling. Here you can see another kind of target, which is a simpler target, and we are using that for the RGB distortion, for the distortion of the RGB cameras, because they have kind of like a fisheye effect with the lens, and we have to correct that in real time, so you can get a good sense of reality when you're looking through Lynx, especially in video see-through mode. All right, and on this table here, you have one other prototype we are building, which has a very cool faceplate, and we will probably finish mounting this one tomorrow. But as you can see, this is the number 25 of prototypes we are building, and you will see it probably in the news at the end of the year when some people will put it on. If we move here, we can see like other VR headset like HoloLens, AR headset like HoloLens 2. That's the Vive Focus, that's the Quest 1, and that's the Quest 2, and here is the Lynx headset. And what is very impressive, if I take another Lynx prototype, is the size of the device, which is much closer than HoloLens 2. If we talk about the front part of the device, it's much less bulkier, I would say. So HoloLens did a very good job, with the Quest 2. What they've done on the hardware is very impressive. And we've been able to make something very slim as well. As you can see here, that's the Quest 2 and the Lynx front face. We also have the battery at the back, which is much better for weight distribution. And I think it was a very good choice. This is also the choice that the HoloLens team made for HoloLens 2. All right, so I just wanted to add that we're also using the robot to see to test all the physical mechanism of Lynx, if it can handle like 10,000 rotation on the knob at the back of the head and stuff like that. But we're mainly using that for self-calibration of the cameras. Then to this bench, that's where we're working, as I told you, this is Lynx without all the mechanical parts here. If you can see on the screen, we're trying not to show too much, but we like to show our work and see that we are doing very cool hardware stuff. And that is here, that's the calibration setup for the optical lens that we're using in Lynx. It's a very specific and complicated setup, and we'll make another video later, probably next week or in the next 2 weeks about that. Okay, so let's get back to the mainland. All right, so next slide. So just a quick word about our lens system, and you should see on the slides what we are doing with that. So on the left image, you have the image display on the LCD, and on the right you have what you should see through the headset. That's an example where you are, let's say, in VR, and we are putting more pixel resolution on the center and along the axis, and I'm trying to show that with the green lines here. You can see on the left, and when we will be able to make you experience the device, this is where you should see more pixel density and more resolution. So we are very excited for that. We're trying, with the COVID situation, we're trying to have the people experience our device. I know it's a very tough time, but we're excited. We finally can send the device to our customers and first partners. So if you think you are one of them, please message me or send us something so we can add you to the list of the people who will receive a headset. And so right now we'll take questions and discuss with you. So maybe I can view the chat, and you can, yeah. All right, so let's see if there are any questions. Any information on latency expected for the video pass-through? That's a great question from Neil. Hi, Neil. So the latency, what we're seeing today, we have something between 12 and 18 milliseconds of latency for video see-through, with the both RGB synchronized with the display. And we're working on that. I think it will fluctuate a little, but you should expect something around maybe between 12 and 15 milliseconds. It's a very, very good result based on the platform that we're working based on the hardware platform we are. I really can't wait. Did you still have the stream? Yeah, you can do. I think the question is about remote rendering. Oh no, sorry. It was because the stream. Can you talk a little about the displays? Yeah, I can talk a little about the display. If someone can give me one of the displays, please. So the GDI display, they are from GDI, Japan Display, and they have a very specific shape that is used by our lens. So thank you very much. So this is a display module that is in Lynx. So you see, it's very small, and we're putting the lens on top of that. So it's a 1600 by 1600 LCD RGB display, and it's the current frame rate is 90 yards. Yeah, so that's it for the displays. What is a new black point in the middle done on face? That's a good question. The black point is actually a glass with AR coating, which means that it only lets AR light go through, because behind that we have LEDs that are used for fluid illumination of your hands. So this is used by the hand tracking algorithm, so we can illuminate your hands in the images and quickly find them with the ultra deep algorithm. And those LEDs are synchronized with the monochrome cameras, so that we can only light them when they would be in use. What type of speed should we expect from remote rendering with Usbc and Wi-Fi 6? Mark, can you help me on that? The speed on Wi-Fi 6 or Usbc for the remote rendering? Do you have any numbers on that? 120 megabytes per second for both, and it's limited to that. Another question from Alpha Omega. Will adding another sensor connected to USB-C add latency to the video pass-through feed? So that shouldn't, if you customize Lynx and add a sensor or a connected device over Wi-Fi, that shouldn't have that shouldn't have a big impact on the video see-through, because it's a very dedicated part of the hardware that we're using for video see-through. So I think you will see a drop in FPS on the display before you see a drop of the frame rate of the cameras. All right. That is the new black point. Do we have any other questions? No. I can see that Rodolphe is still trying to send me some messages. All right. So I think that's all for today. Oh. Yeah. So I think that's it for today. And again, if you have any other questions, we will host another event probably next month, the same kind of event, and at this time we will show new kind of experiences and video through the lens of the headset in a correct setup. We have to think about that, because it's quite difficult, and we don't want to show It's not a question about not showing good images or bad images. It's just that we want to deliver something that is close to what you get when you're really wearing the device. And that's too bad that we don't have CES this year or any kind of big events. We'll have to think through something with the press. So yeah, we'll keep you updated on that. And thanks again for tonight. Thank you.